Right, so review for 5.2, you need to know your basic exponent rules. When you have the same base and you divide, you subtract the exponents. When you have the same base and you multiply, you add your exponents. When you're raising an exponent to another exponent, you multiply them together. And when you have a negative exponent, it means you can move it to the denominator and make the exponent positive. Okay, so those are the basic rules of exponents that'll come in handy to do some problems. Number 11 on the review, we have 6 to the 2/5 over 6 to the 1/5, and we have it all raised to the 3rd power. So the exponent rule we're going to use is this one. We're going to subtract our exponents because our bases are the same. So if I have 2/5 minus 1/5, that's going to give me 6 to the 1/5 power. And now I have a 1/5 raised to the 3rd, so I'm going to multiply those exponents together. 1 times 3, and 5 on the bottom. Remember, there's a 1 on the bottom here, so it's 5 times 1, so it's 6 to the 3/5. You could leave your answer like that, or you could rewrite it as a radical. It means the same thing, either way. But that's as far as we could go with that one. Number 12, we have the 4th root of 32, and we have the 4th root of 8. We can do this problem a lot of ways, okay? We're trying to simplify. So when we're trying to simplify and we look at the root, we're trying to find numbers that have an integer for this root. So like the 4th root of 16 is 2. So if I can make a 16 out of any of this, that's going to help me simplify. Okay, other ones to think about would be like the 4th root of 81 is a 3, right? Those are two common ones that we would probably use. 32 is 16 times 2. So I can split that 32 up into the 4th root of 16 and the 4th root of 2. Okay, this part, just this 32, is getting split up and rewritten. The 4th root of 16 is 2. So just this part is equal to this expression. Okay, none of these, 16 doesn't go into 8, right? 81 doesn't go into 8, so I just carry this down. Whatever's left under the radicals can get multiplied together. So 2 times 8 gives me 16. Then if you can simplify that any farther, you simplify it. So this 2 on the outside stays, and then this radical also becomes a 2. So I multiply those together to get my final answer of 4. Number 13, we have to rationalize. When we rationalize and we have a binomial, we multiply by the conjugate on the top and bottom. The conjugate means I need to change the sign in front of the radical. On the top, it's just 1 times 2 and 1 times the square root of 7. So 2 plus the square root of 7. On the bottom, we're multiplying these binomials. So 2 times 2 is 4, 2 times the square root of 7, and then minus 2 times the square root of 7, and then minus the square root of 49. If I simplify, this part becomes minus 7, and these cancel out. So in the top, it's 2 plus the square root of 7. In the bottom, it's 4 minus 7, so it's negative 3. Okay, number 14. Number 14, we're looking to see if we can simplify. I like to split them up so that you have your coefficient as one problem and your variable as another problem. I'm looking to see if I can take the 5th root of 125. So I'd be looking for numbers that can be a 5th power that would go into 125. There aren't any, so we're just leave it like that. And then this is x to the 10 over 5, which is x squared. So I can write my final answer like this. Number 15, we have the cubed root of 9, the cubed root of a to the 12th, and b to the 3rd. So the cubed root of 9 stays. This is a to the 12 over 3, b to the 3 over 3. So it's a to the 4th, b to the 1st, and then the cubed root of 9. Number 16, we're going to have to use our rules and subtract our exponents. We have m to the 7th, but then we have n to the 2nd over n to the 9th, which is going to give me n to the negative 7. Since it's a negative, I'm going to put that in the bottom. I'm taking the 7th root on the top and the 7th root on the bottom, so it's just m over n.